Hi, welcome back to this YouTube channel. In today's video, we're going to look at how to find the divergence and the curl of a vector function. So let's just get right into it. Now, we just need to understand how the formulas that we use to find this divergence of a function. So let's just state both of them for curl as well. So divergence of f is just given as, and this is extremely important, is the inner product, right? So inner product is basically the dot product, right? So let's just say the inner product of what? The grad operator. So what's the grad operator? So let me just create a space here. So the grad operator for this vector field is, of this vector function is this. So this is the grad operator, right? Right? So the grad operator and what? And the components of this function, right? So the first component, so let's write it. So let's say the first component is this, second component is this, and third component is this, right? So this is how to find the divergence of a particular function. So in this case, the first component for this particular function is xz, second component is what? Xyz, and the third component is what? Minus y squared. So basically, that's what I'm talking about. Now, what about the curl of a function, of a vector function? So this is actually the cross product of this grad operator and then the function itself, right? Which would be comprising this f1, f2, f3. So let's just apply this and see for this particular problem how we find the divergence and the curl of this function. Okay, so the first one, the divergence of f. Now this is quite easy. Like I said, it's either you look at it as and just say, is this the dot product of this with f, which is the inner product of this grad operator and the function itself, components of this function. So it depends on how you want to operate this. So this is basically, so let's call it the dot product, which is d dx, d dy, sorry, d dy, and then d dz, dot product with what? f1, which is xz, f2, xyz, and f3 minus y squared. Okay, so what is this? This is just d dx of the first component here of xz plus, that is how dot product works, is this product of this and this plus product of this and the second component, then product of the third one and the third component. So the next one is d dy multiplied by what? xyz, and the last one is d dz of what? Minus y squared. So this is what we call the divergence of f. So d dx of xz, so derivative of this, partial derivative of this with respect to x is just going to be z, right? And then partial derivative of this with respect to y is going to be xz, and the partial derivative of this with respect to z is going to be 0, right? So the answer to this problem is this. So for divergence of f. Now let's move to the curl of f. Now the curl of f, so remember, it's just the cross product of this grad operator and the function itself. So another way to write it in terms of matrix form is to say is the determinant. So where the first component ijk, and then we have the grad operator d dy, then d dz. Then you now have your f components. The first component is here, second component would be here, and the third component will be here. So it's the determinant of this that gives us the curl of f. So what's the determinant? It's basically I. We start with I, then we find the determinant of, if we cross out the row that I and the row and column that I belongs to. So that will give us the determinant of this. So I think it's better I write it in full. That will give us the determinant. So instead of writing determinant, let me just use the same notation. So that will just give us the determinant of what? d dy, d dz, as you can see, xyz minus y squared. Then we come to the second one, minus j. Okay, then the determinant of cross the column and the row J belongs to, what will be left is d dx, here will be d dz, then we'll have xz here, we'll have minus y squared here. Okay, then plus z, determinant of not z, k in this case. Okay, so k is the third component. Okay, so k, we'll cross out the row and column k belongs to, so what we'll have is d dx here, d dy here, and we have xz, xyz here. Okay, so now let's complete this. So we have y, determinant of this is just the product of d dy of, so let me write it, is d dy of minus y squared, then minus d dz, as you can see, of xyz, because the determinant of this is this multiplied by this minus this multiplied by this. Okay, so this is how we got this. Then we go to, so j is the next one. So we're going to write everything out for the learning purpose. If not, I could have just skipped this step and just find the derivative of this with respect to y squared directly. But let's just take it step by step. So now here is minus j. So determinant of this again is this times this minus this times this. So that is d dx of minus y squared minus d dz of xz. Awesome. Then the third one, basically, let's just quickly write it. d dx of xyz minus d dy of what? Xz. Perfect. Now let's quickly finish this problem. Now d dy of this is just minus 2y. Now d dz of this is minus xy. Okay, good. Now minus j, d dx of this is 0, d dz of this is minus x. Okay, and finally, the last component, d dx of this is just yz, then d dy of this is 0, as you can see, because there's no y in this function. Okay, so let's finish this. So this gives us minus 2y minus xy I, then minus j times minus x, that's plus xj, then finally k times yz plus yzk. Now this is the answer to the problem. It's a vector, and that is called the curl of f. So that gives us so these two gives us the answers of what you're looking for, and that brings us to the end of the video. Please don't forget to like and subscribe to the channel. Comment down below of any question or any problem you would like to see on the channel, and I'll see you in the next video.